These are the things we use for our project. First, we use a bottle, knife, scissors, screwdriver, needle, nails, lighter, ruler and marker. We mark 2 points at the bottle, one at the top of the bottle for the inlet, another one at the bottom of the bottle for the outflow. We heated the needle to put a hole so that it will be easy to put a hole on the bottle. Then we use a scissor to cut the holes. This is the inlet of the bottle, and this is the outflow of the bottle. The diameter of the inlet is 1.7 cm. The diameter of the outlet is 1.1 cm. The pipe is inserted into the inlet hole to let the water flow inside the bottle.
Now we proceed with the finding the GP for our experiment. So we will show you the first one. the first data that we obtained from our experiment, which the time and also the water level. Then the next to it is S1, S2, S3, S4, S5, and S6, and also S7. This we obtain through the step change that we use for our experiments. There are 7 step change that we included in our experiment. The first one is 95, 15, 30, 35, 55, 52, and also 55. And the step change change at the time 0, 25, 30, 53, 76, 125, and lastly 138. And through regression, we obtain this plot whereby the blue one is the actual graph, while the orange one is the plot that we obtain using the regression data. So from the regression that we have done, so we obtain the GP, whereby the theta, which representing the time delay, equal to 0. Our gain is 0.055768, and lastly our tau is 5.202152. Okay, now we continue with the finding the GC. So since we are using the PID controller, so we are going to use the IMC table to obtain our KC, tau I, and also tau D. So from the GP that we obtained just now, combining with our GM and GV, which we assume to be 1, so our GS is equal to our GP, which our transfer function is only first order transfer function without the time delay. So from the IMC table, we are using the model A, which the model A only give us the tau C and also tau KC and also the tau I only. There is no tau D, so we just put it 0 there. So before we can proceed with the finding for our KC and also tau I, first we must guess our tau C. So we are using the guessing factor, which we guess from where our tau C must be in between our tau and also our theta, which our time delay. So our time delay is equal to 0, whereby our tau is equal to 5.202152. So we decided to use 0.5 to 5 for our tau C, with increment of 0.5 each. So this is our KC, tau I, and the below one is our P and I part for our PI controller. So from this 10 data, we actually are going to use only the highest 5 from this PI controller that we obtained. So next we are going to proceed with our simulation part. So this is our Simulink. Okay, I will explain from the top part. So this is our simulation. This is our gain, our GP. This gain represent the GV, and the other gain represent the GM, since both GM and GV we assume to be 1. So we go down to the below, since we are going to use the PID controller. So these are the simulation blocks that we are going to use. So we are going to run this. Okay, now let's see the result. Sorry. Okay, this is the result for our simulations. So as we could see, the yellow one is the highest tau C that we use, is which is the 5. The purple one is tau C at 4.5, 4, 3.5 and 3. So as we could see, the lowest the tau C is better for our controller, since it gives a faster response, and also it also stabilize faster than the others.